We have gone way too far while crafting our custom retrieval of data items stored in our linked list, but we have not analyzed the code what we have written so far, right? Let's discuss about the architectural goals that we set for this retrieval. Let's analyze what we have achieved so far and also go through IEnumerable and IEnumerator interface implementation so that we have a better understanding why we have two interfaces, IEnumerable and IEnumerator, to fetch the data out of our linked list. So let's go to our own custom list implementation. So what we have done here. Hey everyone, and welcome to third episode of Link in Depth series. I'm Munir Hussain, a senior software engineer and an architect with over a decade of experience working on .NET platform and a part-time instructor at TED. In this episode, we are going to dive deep into enumerators in C#. That said, we will be checking out IEnumerable and IEnumerator interface 1000 feet below at IL level. These interfaces have been essential toolkit of every C# developer for years together, and their knowledge and how they are implemented are indispensable to every C# developer. This episode is packed with full of concepts and demonstrations. Let's have a brief look at what we will cover. As said, we will be inspecting IEnumerable and IEnumerator in depth. IEnumerable and IEnumerator are interfaces that allow for sequential access to elements in a collection without exposing the internal structure of the collection. The philosophy behind these interfaces is based on encapsulation and decoupling iteration logic from data storage. We will have full demonstration on this to realize this power, implementing both generic as well as non-generic versions of these interfaces. We'll see why two separate interfaces, IEnumerable and IEnumerator, were defined by Microsoft, the philosophy behind this. We'll be writing our own linked list in its basic form and see how these interfaces can be implemented. We will see how correct implementation of these interfaces give rise to the effect called deferred execution, which drastically improves the performance of the application. We will see what is the hype about state machines as defined in the Microsoft documentation when defining the deferred execution. We'll be checking out Foreach Loop and how these interfaces are connected to it. I'm sure you will love this episode, being a good developer. And what they say, do not forget to like, subscribe, share, and hit that noisy bell icon. So guys, as you know, we will be making a minimal linked list in this episode, and keeping in view the requirements of the episode and the viewers in mind. So coming directly to linked list, I thought it will be nice to have a recap on linked list to regain the concepts before we code. So what is a linked list? A linked list is a data structure containing the nodes chained together. So what are nodes? Nodes are nothing but data structures containing data and the next pointer in them. So the next pointer points to the previous data structure we have made. So let's visually realize this and see a nice recap of linked list. So guys, we have here the first node, and it has data as 2, and the next pointer, since it's a null, since it's the first node, it will be pointing towards nowhere. So its value is null, and we have an address of 1284 of this first node, and then we make a head variable which obviously will reside in stack, will not be assigning anything when we create it, and then we assign it the address of this first node, and the thing goes on. We have second node as data is 30, and next pointing towards the address of the previous node as the arrow shows, 1284. So, and the thing is that the head will be pointing towards the latest node, and its address will be 2372. It will hold the address of this newly created data structure or node, and this will become our first node. And then it goes on making the third node over here. So it will have an address of 1, 2, 3, 4, and it will point towards the node having address 2372 as shown by the arrow. So then the head will contain the value, the address of this newly created node, and it will become the first node. Fine. First node, I mean to say, we will be having this head as the starting point, wherein we can maybe loop through or whatever logic we will be making, like we will be making use of the state machine. So let us see how we can efficiently build this linked list and make use of IEnumerable and IEnumerator in this episode. Let's jump into the code. So guys, I have opened the same project in Visual Studio we left with in the previous episode, episode 2. Here we will be making our own linked list so as to demonstrate the power of IEnumerable and IEnumerator interface. So let's go to Solution Explorer and create a folder with name dynamic collections and a class with custom list as name within this folder. Let's make this class as public and generate, and let it inherit from IEnumerable of T interface and implement the interface. So what we wrote here is a class named custom list inheriting from IEnumerable of T. Let's quickly inspect this IEnumerable of T. Going to definition, it has got only one method, get enumerator, and returning IEnumerable of T, right? And this IEnumerable of T, the generic version, inherits from the non-generic version of IEnumerable. Let's go quickly inspect this. It has also got get enumerator, which returns IEnumerator. So what is the logic behind this thing IEnumerable of T and IEnumerable is that the IEnumerable, the non-generic version, was introduced in .NET 1.0, and this was the generic version was introduced in, I think, in 3.0, if I'm correct. So for backward compatibility, we have to implement both of the functions of this IEnumerable and this generic version IEnumerable of T. So since the generic version is inheriting from IEnumerable the non-generic version. So in effect, therefore we got two methods, this method and this method, the non-generic version and the generic version. Fine. So when we create a linked list, it consists of nodes. So let's quickly make a node by creating a class over here. So what we wrote here is a class called node, which will act as the building block, the unit of linked list. It has got two fields, the data field and the next field. The data is of type T, which will be passed along when we create the object of this custom list class. And the other field is the next field, which will store the pointer to the next node in the chain. So if you are glaring about this on this default not thing, the not is called the null forgiving operator, and the default is whatever default for this data field is, just assign it. So if we just remove, if we can remove this, if we will remove this thing, Control X, and see, it's giving me a green skewedly. So it's telling me either make it required or make it nullable, so that at the end of the day, when we return from this class, this data should have some value in it, right? So let's restore it. And this next field, same thing. I just assigned a default of not the null forgiving operator. So it will be assigned null value because it's of type a node, the reference type. So the default value of node will be null, right? So I'm assigning the default value over here because I cannot beforehand make any decision what address this next thing, the next pointer will hold, right? So it can only be decided at runtime when we make the linked list. What we have created here is a node class which will act as a container for creating the elements of the linked list, but we are not doing anything with it. So let's add some functionality over here by writing a function which will create a linked list and for adding the nodes to the linked list. Let me write the function over here and then we will come over it. What we have created here is a head field of type node which will store the address of the first element of the linked list chain. By the way, we have a mistake over here. This node class should be private. The external world has nothing to do with this node class. It is concerned only with the data, not with the whole class, right? So we'll be exposing this data part to the external world via some function when we write some code to retrieve the data stored in the linked list. Back to the function we just created, its name is add, which will create a linked list for us, accepting the item of type T to be stored in the linked list. Let's go over to the body of this add function. We are creating over here, we are creating a object n of type node, and then we are assigning the data part of this n object to be the item, and then the next pointer head towards or point towards the head, and then we are assigning this newly created node, the address of this newly created node, to the head. Bring your attention to line number 20, line number 22, and line number 23. We will have a quick dry run over here. So the first time the add function when called will create a node over here, and then the next part will contain the address of the head. The first time it comes in, it will have the value null in it, and then in the next part we are assigning the address of the newly created node n over here to be the head. So when the add function will again be called, we will create a node, and then the next part, the next pointer will store the address of the previous head, right? The previous head we previously created, and then the newly created node will be the head of the chain. We successfully created the linked list chain. Great job. But we should also have a functionality to retrieve the data stored in the linked list chain. That's where this IEnumerable of T comes into play. We have to implement both the non-generic version of the get enumerator and the generic version of the get enumerator function. So let's implement the non-generic version of this get enumerator first. We just have to return the get enumerator over here, which will call the generic version of the get enumerator, which we want. But just in case you are wondering, it will be a recursive call to the same function. So that's not the case. This is IEnumerable dot get enumerator. So it will call the generic version, which is only the get enumerator. Coming to generic version of this get enumerator, so what it is saying? So it's saying that you should create a type which should inherit from this IEnumerator of T interface and return that object back to the caller. Let's do that. Let's pass the head to the constructor of this type and pass control period and generate the type over here. Let's create a nested class over here. So it's again complaining over here. So we have to implement it, right? But again, the red squiggly over here has gone, but we have a red squiggly over here. So let's say we have to generate the constructor in this enumerator class, right? So let's quickly go over here in the enumerator class. What we have here is the class enumerator, whose job is to retrieve the data we just stored in our linked list. So it's inheriting from IEnumerator of P. Let's go to definition over here and see what we should implement. So it has got only one property called current, and its job, the current will retrieve the current item in the list, as we will see when we implement the functionality. And the IEnumerator of P inherits from IEnumerator the non-generic version of this IEnumerator of P and the IDisposable. Let's go to IEnumerator here, and it has got one property current, the same property, the one which the generic version have, and the MoveNext and reset. The functionality of reset is to reset the current pointer to the start of the list. And this MoveNext, the whole thing goes over here. So we will be writing the functionality in MoveNext to retrieve all of the items from the list we created. So let's go back, and this IDisposable. So let's go to definition and see what's here. So this IDisposable interface has got only one function which we have to implement. It's used to dispose of the things or the resources which are not disposed by the .NET framework. .NET framework only disposes of the in-memory objects. The resources which are external to the system, like the network connection, the database connection, or the file handlers, which we should dispose of here. Let's go back. So what we have here is the reset function. Let's go over here. This reset function, its job is to reset the pointer to the start of the list. We will not be implementing this thing. The reason being is that the external user can do some nasty things to the list if we just implement this thing. The .NET framework also have not implemented this functionality. So let's close it. Next is the MoveNext. We'll go over it in a bit. Next is the dispose function. We have nothing to dispose over here. However, we will have some functionality dispose of the state, as we will see. Then we have the non-generic and the generic version of the current property. So let's implement the non-generic version first. We just have to return the generic version here, current, and it's saying the same thing. Let's fix it, the nullable thing. So let's make it nullable, and we are done. So here we will be returning the current property. Let's control dot generate a variable. Okay, I'm okay with that. And then it's having some green squiggly over here. So the current, so let's give it a setup call over here, default of null forgiving operator. The main part of this class is this MoveNext function. So what we will be doing over here to retrieve the item from the list, we will loop through, not actually looping. We will just retrieve the data from the list over here. So for a moment, let's return true over here and put a breakpoint over here so that we can get a sense what we will be doing here. So let's go to program.cs, and what we doing here is create an instance of this custom list of, let's have it as of type int, and then list.add. I'm okay with it. 2, 3, 4. List dot add 4. So I'm okay with the 4 items. And then what we will be doing is list dot get enumerator over here. So it will return IEnumerator of T or int over here, and let's name it enumerator. Fine. And then while enumerator dot MoveNext, so let's console dot write dot write line. Let's do one thing, copy, and let's comment it out for a moment and paste it over here and write something over here. So inside MoveNext function. So let's go back to custom list and put a breakpoint over here also, and put a breakpoint over here so that we can inspect everything what we are trying to do. Let's run it and see what we are getting. Before we run the program, let's go to program.cs and put a breakpoint over here also and run the project. Okay. Let's step into. Okay. That's okay. We are adding an item to the list. Okay. Okay. Then adding 2. So we have 3, and in the next part we have 2, and in the next part we have 1. Seems the linked list has been constructed successfully, right? So let's get rid of this breakpoint over here and press continue. So what's hit here, the get enumerator. So let's step into. So we are going to constructor and this. Now we are enumerating the thing. So we are hitting into MoveNext. Let's step into. So we are getting the output, right? Now let's go over it. True. Let's go over it again. True. So what we have here is, while the MoveNext is returning true, we are looping through the external while loop. So what we will be doing is to write a functionality such that the data we will be retrieving the data and make this while loop and this MoveNext work together to retrieve the data. Fine. So let's do it and let's see how to implement it. So what is the first requirement to do over here is to retrieve the address of the first element in the list. Where can we retrieve that? In the head. So let's make a node, a reference over here is equal to head, right? Then what's the second requirement? Then we have to assign the current property to be n dot data, so that the client can retrieve the current property via this current property, this private property from this current property back to the caller. So what's the next thing? We just have to set n is equal to n dot next. So the line number 60, n is equal to n dot next, will reset the pointer to the next element in the linked list chain. This will ensure that while we are getting the data from the current node, we also get the pointer to advance to the next node in the next iteration, so that we can also get the data from the next node in the linked list chain. So we have written some functionality. It's a partial functionality over here, but there is a problem over here. Now we have to, every time we get into this MoveNext, we are assigning the head to it. So effectively, we will be getting the same data over and again. So what is the solution to this problem? To mitigate this problem, we will introduce a property called state at the top of type int and set it to 0 at the very first place. And then what we will be doing over here, checking if underscore state equal to 0, and then we will be setting the node to be head and elevate this node outside the if block and setting it to default of null forgiving operator. So get rid of node over here. While we are in this if block, let us change the state to be 1, so that the next time it comes in, it will see the state variable is set to 1, not 0. So it will never come back and execute this if block, right? And we're done, right? So we get rid of that reassigning the head to n again and again, while we are hopping in and out of this MoveNext. So next thing, we are almost done. We have to see how we can exit the loop. To exit the loop, we will check if n equal to null, we will be returning false. We are almost done, except some senti checks over here. Let's add a try catch block to handle any exceptions, if at all, happens here, and catch the exceptions. Throw the exception back to the caller, and finally we will just dispose of the things over here, and in the dispose function, go to definition, we will set the state to be some invalid state, right? And I think we are done. So let's quickly run the functionality and see what we get. So let's step over here and get the enumerator, initializations. So in the loop. So by the way, we have to uncomment the thing over here, so that we can retrieve the actual data. So let's uncomment and run the project again. Let's step over here and get the enumerator, initialization over here, and back into the loop. In the try catch block, MoveNext, state 1, and we are retrieving the things. So MoveNext, are we getting some data? Yes, we got the 4. So next, n is equal to null. So seems there is a problem over here. So let's quickly fix that. So let's go to custom list. I deliberately leave this error over here. So the error is here. So what it says is that like while we are hopping in and out of this MoveNext thing, the garbage collector just come in and garbage collect this node because it's getting out of scope. So the scope of this class, the object of this class, and the scope of this node n is different. So garbage collector sees it and just garbage collect the node thing. The solution to this is to make this as a property to mitigate the thing over here and get rid of this. Let's run the thing over here again and see what we can get. See, we get the data, right? So let's go back to program.cs and comment out these lines of code by which we were looping through the data and make use of Foreach loop. Let's see whether we can do this. Let's run it. See, we get the same data we were getting by executing these lines of code. So what's the logic behind? It's a simple thing. So the compiler is generating this above code for this Foreach loop, right? So this is compact way of thinking, compact way of saying this thing, right? Let's analyze what we have achieved so far and also go through IEnumerable and IEnumerator interface implementation so that we have a better understanding why we have two interfaces, IEnumerable and IEnumerator, to fetch the data out of our linked list. So let's go to our own custom list implementation. So what we have done here is this custom list class. We created the custom list class and a nested node over here, and then created the linked list chain, adding the data items we are getting from the client, the item, right? And then we inherited from IEnumerable of t. So the IEnumerable of t has got two methods, the non-generic version and the generic version. We implemented both of them. In effect, we are implementing IEnumerator of t interface and returning the implementation IEnumerator back to the caller. We have gone way too far while crafting our custom retrieval of data items stored in our linked list, but we have not analyzed the code what we have written so far, right? Let's discuss about the architectural goals that we set for this retrieval. Number one, we should be able to enumerate through the list in order to get the data items which we store in the list. The list is of no use if we store data but not retrieve them. We have successfully achieved that, right? What is the second goal? We should be able to provide the user of our class to enumerate the list as easily as possible. We should hide the low-level implementation details to the user while still be able to access the enumeration or list and expose only the details which are useful to him or her. He or she should be concentrated on his own problems, solving her own business problems, or the tasks he or she is assigned to, not solving the issues related to our enumeration or list. We have successfully achieved that by encapsulating the functionality in our own custom list class and the enumerator class, abstracting away the implementation details through implementing the interfaces IEnumerator and IEnumerable interfaces and exposing the details which are important to the user. The get enumerator and the MoveNext function did the great job for us. The user is somehow relieved. Now we want more. We don't want the user to explicitly call the get enumerator and looping through the collection while MoveNext returns true as well. If we achieve this, that would be an excellent work. that would give a user a nice experience, that would hide the details completely. That's why Foreach Loop was created by Microsoft, and when compiled, it emits the same code. Call to the get enumerator and a while loop looping through while MoveNext returns true. This gives the user the same feeling as he or she is looping through an array which he or she was used to in the past. This completely relieved the user. Now he or she can concentrate on his or her work, solving his or own tasks. Great job, needs a thumbs up. Number third, we should also be able to access the elements through index as well, as we were doing while accessing the array. While this can be achieved through indexers in C#, accessing any collection other than array is very expensive operation. It's because an array is contiguous memory allocation and its access through index is inbuilt to any underlying system architecture, which gives the random access capabilities to arrays out of the box. As far as our list is concerned, the memory allocation is not contiguous and is only accessible through memory addresses. We can camouflage this behavior. In fact, Microsoft has done this through indexers, but remember, accessing collections other than arrays is a very expensive operation, because accessing through index means either finding the item by looping through all of the collection or making an array to store the address of the nodes. Either way, this is not ideal, which boils down to the fact you should always try to access the collection other than array through Foreach Loop. So here's the question. Why did Microsoft decide to have separate interfaces for the retrieval process of their collections? The reason being threefold. Let us suppose we are in the nested loop, and imagine while we are in the outer loop, we happen to execute the inner loop. Now, what our implementation returns is a new enumerator every time a call to the get enumerator is made. Good. Now, if it had been the case we had only one interface to implement, say IEnumerator, that would cause the retrieval of the same instance and the same state of the retrieval process, no matter how many times we call the get enumerator method. This will cause the sharing of the current position of the iterator as well. The result would be that the inner loop would start looping through the collection where the outer loop left with. That's clearly a bug. We don't want that to happen. We want the nested loop to start from the start of the list by default, right? Number two, by returning a new instance every time a new call to the get enumerator is done. Here, we are returning a new instance back to the caller. This means the retrieval process is thread safe. Every thread will get its own instance of get enumerator on the same list. We are not sharing any state here for the retrieval process, and hence we also not need to manage the threads, right? Number third, by logic, the enumerator give rise to the effect called deferred execution, which drastically improves the performance of the application. The logic we wrote is the deferred execution in its true form, as we will see when we discuss link. Number four, we will also see what we discuss when we discuss the link, that the yield statement, when compiled, emits the same code when hopping in and out of the loop. So let's go to the implementation of this IEnumerator interface, the enumerator, which is also known as the iterator, because we are iterating through the list by the way of this enumerator, right, or the iterator, right? So let's go to this, go to definition over here. The main center of focus in this enumerator is this MoveNext thing, right? MoveNext function. So inside the body of the loop, we are intelligently making use of the state variable, and also we are making use of this current property, fine. So this property is available via the current property, the public current property, fine. This is the private property, right? So to maintain the state of the loop, like where we are currently, this is maintained by this state variable. So whether we have entered in this MoveNext function previously or not, fine. So this is called the state machine, because we are maintaining different states of this enumerator at different points of time. So this is what Microsoft calls as state machine. If we go to Microsoft documentation, you can go to this link and come to technical implementation. It clearly says, although you write an iterator as a method, the compiler translates it into nested class, which we did. In fact, a state machine, we also implemented that. This class keeps track of the position of the iterator as long as the Foreach loop in the client code continues, fine. It's explaining the same thing, fine. So we maintain the state by state machine. I'm sensing you should already have realized that this code is highly performant. We cannot say it. We have to measure the performance of the code. So the performance thing requires an episode of its own. At the end of the course, I will be making a full-blown episode on this topic, wherein we will come back to this custom list and measure the performance. So bear with me. I promise we'll measure the performance of the code, wherein I will show you how to measure the performance from Visual Studio, as well as we'll also inspect benchmark.net to measure the performance of our custom list. I hope, guys, you enjoyed this episode. Keep practicing, and this code will be available on my GitHub account just in case you need it. See you in the next episode. Thank you.